Hello, this is going to be lesson B10 on multiply and divide radicals. It's found on section 11.3 of your book. Example number 1, we're going to multiply different radicals. See example A, we're trying to multiply square root of 2 times square root of 7. We can go ahead and multiply that because they both have the same root, which is square root. So that means I can write the whole thing under one radical. So instead of writing square root of 2 times square root of 7, I can write square root of 2 times 7, which in other words equals square root of 14. Letter B is a similar problem. We have square root of 17 times square root of y. Because both are square roots, I can go ahead and multiply, so I have 17y, or the square root of 17y. Next one, I have cube root of 2 times the cube root of 32. Because they're both cube roots, I can write under the same radical. And I'm going to take one step further and do the prime factorization of 32, which by doing it, I get 2 to the 5th. So that's why I write here 2 to the 5th. So I got this 2 right here, from here, and I got 2 to the 5th by doing the prime factorization of 32. Now, 2 to the 1st times 2 to the 2nd, you have the same base, so what can you do with the exponent? You can add, so I get 2 to the 6th. And that's great because 6 can be divided by 3, so that means the 2 can come out of the radical as 2 to the 2nd, and the final answer then is 4. Very well, let's continue on to the next problems here. We have letter D and E. Again, we have the same radical, the 4th root. So what I'm going to do is do the prime factorization of 6, which is 2 times 3. Prime factorization of 8, which is 2 to the 3rd power. And I'm going to write everything under the same radical of the 4th root. So this would be 2 to the 1st times 3 to the 1st times 2 to the 3rd times x to the 5th. Now I'm going to try to remove as many numbers as I can from the radical. And so I'm going to rewrite these numbers. I see I have 2 to the 3rd and 2 to the 1st, which becomes 2 to the 4th. That's awesome because I can remove that from the radical. The 3 to the 1st, I'm just going to bring it down. X to the 5th, I'm going to break down as x to the 4th and x to the 1st. Now that I have done that, I notice that 2 to the 4th and x to the 4th can come out of the radical. And when they do come out of the radical, remember to divide the exponent by the root. So 2 to the 4th, the 4 divided by 4 is 1, so the 2 comes out as 2 to the 1st. Same thing happened with the x. X comes out as x to the 1st. And inside the radical, I have 3x. So 2x, 4th root of 3x. Alright, letter E. We have the same radical, so that means I can write everything under the same radical. So what I'm going to do is 3 times y is 3y, x times 2 is 2x, and there's nothing that can be canceled, so I just leave my answer like that. Alright, so we notice that if we have the same radical, we can write under just one radical. And example number 2, we're going to work backwards. We have y over 36 under the same radical. I can split them into 2 radicals, square root of y, square root of 36. And if you notice, I cannot do anything with the y on top, but with the 36, 36 happens to be a perfect square. So what is the square root of 36? 6. Okay. Same thing I'm going to do here on the letter B. I'm going to split the radical into 2, one on top, one on the bottom. I go ahead and do the prime factorization here on the side. I did the prime factorization of 81, and I got 3 to the 4th. And I noticed that this is a cube root, so instead of writing 3 to the 4th, I went ahead and wrote 3 to the 3rd, 3 to the 1st in preparation to remove something from the radical. I did the prime factorization of the denominator, which gave me 2 to the 6th, and that's perfect because 6 can be divided by 3, so I just wrote 2 to the 6th. I removed things from the radical, so the 3 to the 3rd came out as 3 to the 1st, 2 to the 6th come out as 2 to the 2nd, and there's only a 3 here that remained on top there. Okay, and basically there's nothing I can cancel. The only thing I can do is 2 to the second is 4. So this would be my final answer right here. Okay. All right, let's continue on to the next example. The next example is the fifth root of 7 over 32 x to the fifth. And again, I split the radical into the top and the bottom. I went ahead and did the prime factorization of 32 and got 2 to the fifth, which is great because this is a fifth root. So we wanted the exponent to be divisible by 5, which they are. So they both come out. So they come out as 2x. And on top I have the fifth root of 7. All right. So that is basically example number 2. Let's go on to example number 3. Example number 3, I have a square root of 75 divided by square root of 3. Okay, now we're going to work the following way. They have the same radical, both are square roots, so that means I can write under the same radical, and 75 divided by 3 is 25, and the square root of 25 is 5. So I can start out with 2 radicals and make into 1 and do the division inside the radical. Okay, same thing, similar thing is going to happen here. 80y divided by 5 is 16y, and the square root of 16 is 4. There's the y cannot come out, so the y stays in the radical and is divided by 3. So that's my final answer right there. Okay, I believe in class that was a question, and basically, you know, I did it this way, what I did mentally, 80 divided by 5. Here I kind of showed to the class that if you want to take extra steps, you could, like writing 1/3 times, and instead of writing 2 radicals, you write 1 radical, 80y divided by 5, which gives you square root of 16y. What is square root of 16 is 4. The 4 comes out, and the y stays inside the radical. Okay, and you can write your answer like this: 4/3 times square root of y, or you can write 4 square root of y divided by 3. Either way, it is correct. Okay. All right, very good. Now let's continue moving on to letter C. All right, they both have cube roots, and first thing I do is I do the division of 162 divided by 3, which is 54. I also go ahead and do the division of x to the 8th divided by x to the 2nd is x to the 6th. Alright, so now I'm going to try to remove things from the radicals. So first thing I do is I do the prime factorization of 54. I break down 54 as 9 times 6, which break down again as 3 times 3, 2 times 3. And I roll this prime factorization inside the radical here. And notice that 3 to the 3rd can get out, and x to the 6th can get out, but the 2 cannot. So they come out as 3 to the 1st, because 3 divided by 3 is 1. And 6 divided by 3 is 2. And the 2 stayed in the house. And the final thing I need to do is finalize this. So 5 times 3 is 15, x squared, cube root of 2. Okay? So basically these are the ideas of the lesson here today, is that the radicals, if you have a radical of the same root, you can write them together as one radical. Okay? And vice versa. If you have a radical like a fraction, you can break it down as 2 radical, 1 radical on top, 1 radical on the bottom. Okay? So that concludes lesson B10. Here are the assignment, where you're going to do some practice problems and then you do the exercise set. Thank you very much for your time and have a wonderful day. Bye-bye.